Hi guys, it's Mrs. Bartlett, and again, I'm broadcasting live from my bedroom, because that's how school works these days. It is day 2, and I'm going to tell you all about the rate of exponential growth. Because remember yesterday we talked about exponential growth of lily pads and the number of cases, confirmed cases of COVID-19. So we're going to talk about that in a little more detail today. What I want to do is compare day 40. So remember, on day 40 of the lily pads population's growth, there were 12.7 billion lily pads. Like, that's a lot of lily pads. On day 40 of the coronavirus cases, though, there were 62,211 confirmed cases. Obviously, that's a big difference. So why? Well, there's two main reasons. Number one, the number of lily pads in the brain teaser doubled exactly every day. So 2 became 4, became 8, became 16, became 13, blah, blah, blah. You get it. In real life, there are variables like weather changes and availability and herbivores. So, if there wasn't as much sunlight, for example, then maybe the lily pads wouldn't have doubled every day. Or if they were being eaten by herbivores in the pond, maybe they wouldn't have doubled every day. And so this would prevent that perfect exponential growth. So the growth of people infected with the COVID-19 virus is real life science. It's not like a brain teaser. In real life, of course, there are a lot of variables, and because of this, the coronavirus line graph doesn't rise as sharply as the lily pad graph. As you can see in the data table to the right, so the one that I created and talked about the other day, the number of infected persons isn't yet doubling on a daily basis the way that the lily pads would have been. In the beginning, in fact, it took like a week, and then a week to double, and then over a week to double. But as the number of infected individuals has continued to rise, so has the spread. So as we look here, now we're starting to see that every 3 days, the number, well, approximately, every 3 days, the number is doubling. So in some cases, it's only taking 2 days. Other times, it's taking 3 days. And there's a reason for that. I got this that is in italics. Well, I'll tell you the source below. But when we're talking about the spread of the disease, of a disease, scientists use a measure known as the reproduction number, or R0. I think it's R0, but it's pronounced R0. This is an estimate of the average number of people who catch the virus from a single infected person. For example, the flu has an R0 value of about 1.3, which means that if you have the flu, you will probably pass it on to 1.3 people on average. Obviously, you're not going to give it to a third of a person, but on average, that's what it is, 1.3. Now, researchers are still working to determine the R0 for COVID-19. Preliminary studies have estimated an R0 value for the new coronavirus to be between 2 and 3, so higher than the flu, according to the Journal of the American Medical Association review study published on February 28th. This means, on average, each infected person spreads the virus to an average of 2 to 3 people. And I've seen it as 2.3 most recently, but that's, about 1 person higher than the flu. Now, in an imaginary world of always optimal conditions, and without any variables, that means that every infected person would always infect, or on average, infect 2 to 3 more people with COVID-19. So if I had the virus, I would infect about 2.3 to 2.5 additional people. This would actually cause the number of cases to grow more quickly than the lily pads because it's more than doubling. So in that perfect lily pad brain teaser, they were going from 1 to 2 to 4 to 8 every other day. COVID has an R0 of between 2 to 3, approximately 2.3. In real life, it's important to note that the R naught is not necessarily a constant number. So you've probably noticed that in some countries, the spread of the disease is higher, and in others, it is lower. Even the same can be said for different states in the United States. It's not a constant number. And the estimates vary by location, and it also depends on factors like how often people come in contact with other people and efforts taken to reduce viral spread. So, for example, social distancing. And there's my source, livescience.com. So in other words, R naught is not set in stone. We can influence those conditions. In fact, if we can get the R naught of any infectious disease below 1 or less, typically the disease will die out on its own. And so that's really the goal of science right now, is to try and get that R naught number to lower than 1. And we'll talk about that more another day. So here you can see this little red guy. He is achoo, sneezing, and he's giving it to, this would be like our lily pads, to 2 people, and each of those are giving it to 2 people, who are giving it to 2 people, who are giving it to 2. But remember, with COVID, it's about 2.3. The second reason for the huge difference in the number of lily pads and confirmed infections on day 40 is because we don't really know how many people are infected at this point. This means we can't precisely track how quickly it's spreading or what kind of variables are affecting the spread. It was easy with the lily pads because we knew that each one was going to, without a doubt, double overnight. We knew they were all in one pond and that they were going to remain in that pond. We didn't need a test to determine if the individual plant was a lily pad or not. We just had to look at it and be like, oh, well, that's a lily pad. COVID-19 tests, on the other hand, are kind of sparse at the moment. Not only are they in limited supply, but it also takes 4 to 10 days to receive the results. Can you imagine how confusing things would be if we could only count the number of lily pads every 4 to 10 days? Like, we wouldn't know that they were doubling necessarily overnight, or if we weren't allowed to count some of them at all. Our data wouldn't be reliable, and the brain teaser would not even be much of a brain teaser. It'd be pretty much impossible to solve. Luckily, a new test for COVID-19 was recently developed, and it is set to give results in 45 minutes. It is scheduled to be released on 3/30, which would be yesterday as of this recording. But at first, it's not going to be widely available. Because of the limited quantities, these rapid tests will only be used to test the patients showing the most obvious symptoms, and until it's more widely used, which it needs to be proven effective first before we use it widespread on everybody. So until that time, everyone else is going to have no choice but to wait 4 to 10 days for the results. So when you see an increase in the number, those are actually people who were tested like 4 to 10 days ago. And so that's the second reason that, that there's that huge difference between the number of lily pads on day 40 day 40, and the number of COVID cases in the United States on day 40. That's it for today. So go complete your questions in Schoology. Bye.